Here we have a math Olympiad question. That is, we have to solve for x in the given equation. 4 to the x to power equals to 1 over x. Okay, so to solve for x in the given equation, on my first step, what I'm going to do is I'm going to get rid of the x that we have as the exponent for the 4 on the left side. So to get rid of the x over here, what I need to do is I have to raise both sides to the power of 1 over x. Okay, let me raise both sides to the power of 1 over x. So 1 over x to the power of 1 over x. Okay, let's consider the power of a power rule in exponent, that is a to the mth power whole to the nth power. Here we have base a and we have exponent m for this base a, and for this complete stuff a to the mth power we have the exponent n. So whenever we have two exponents like this, what we can do is we can multiply these two exponents. That is then we'll be getting m times n, that is a to the power m times n. So I'm just going to use the power rule, the power of a power rule in exponent over here, because here we have the base 4 and we have exponent x for the base 4, and for this complete stuff we have the exponent 1 over x. So what can we do with the two exponents over here? We can multiply the two exponents x and 1 over x. Let me do it in the next step. 4 to the power x times 1 over x, and here we can keep this stuff on the right side as it is, that is 1 over x to the power 1 over x. So when I multiply the x times 1 over x, is x and x will cancel out. I get 4 to the first power. So 4 to the first power is nothing but just 4 equals to 1 over x to the power 1 over x. Here, look at the stuff on the right side. So here the base is 1 over x and the exponent is also 1 over x. So whatever stuff we have at the base, the same stuff we have at the exponent. So can I write this 4 in this pattern? That is, we have to write 4 as a power where the base and the exponent are same as we have over here. Since this 4 is a power of 2, and we can write this 4 as 2 to the second power equals to 1 over x to the power 1 over x. Okay, in whatever pattern we have the stuff on the right side, in the same pattern we have the stuff on the left side. So here the base is 1 over x and the exponent is 1 over x. So here also the base is 2 and the exponent is also 2. So base and exponent are same. So on both sides we have the stuff in the same pattern. Since we have the same pattern on both sides, we can equate the quantities at the same position. Okay, if I consider the quantity at the base over here, I have 2. If I consider the quantity at the base on the right side, it's 1 over x. We can equate them. Otherwise, what we can do is we can compare the quantities at the exponent. So here the exponent is 2, here the exponent is 1 over x. We can equate them. So when I do so, I'm getting 2 equals to 1 over x. Either I can equate the bases or I can equate the exponents, because on both sides we have the same pattern. 2 to the second power 1 over x to the power 1 over x. That is the base and the exponent are same. Okay, now what we need to do is we have to solve for x in this equation. So but here the variable x in denominator. So to solve for x we have to get the variable x in numerator. So now let's take reciprocal on both sides. If I take reciprocal for this 2, it will become 1 over 2, and if I take reciprocal for this 1 over x, it will become x over 1, or simply we can write it as x. So the value of x in the given equation is 1 over 2.